Hello, everyone, and welcome to today's webinar with Clean Horizon, where we'll be learning about the falling costs of battery storage and how to take advantage of cost declines through agile and intelligent procurement strategies. I'm Andy Colthorpe, editor of Energy Storage News, and I'm delighted to introduce a discussion on a topic that will be top of mind for many developers and investors in battery energy storage systems, or BESS. Over the past 15 years or so, the rapidly falling costs of renewable energy have brought solar PV and onshore wind to the point that in 2023, they were cheaper generation sources than both new and existing fossil fuel plants, according to the International Energy Agency. The IEA says the cost of a PV module almost halved during last year alone, with solar accounting for about 3/4 of a total 510 gigawatts of new renewable energy capacity deployed around the world in just 12 months. It has been a similar story for the price of batteries over the past decade, and Europe, the US, and of course China are among the many regions of the world now deploying battery storage in record-breaking amounts every year. Today's speakers will discuss how the industry can best position itself to take advantage of those falling costs and the many factors that need to be considered when planning large-scale battery storage projects or portfolios. The market dynamics can be complicated. For example, while the modules are now the cheapest among the main components in a solar PV system, balance of plant equipment, construction, permitting, and other soft costs can dramatically impact the overall cost of solar projects. Conversely, even with the costs in rapid decline, battery cells still represent the single most capital-intensive investment in a battery storage project from the technology side, and batteries are also far less commoditized than solar modules. Choosing the right equipment is not always about price competition. How the batteries perform at the individual cell level and once integrated into racks, cabinets, and containerized systems, what sort of energy capacity and footprint they fit into, how safe they are to use, and who among the integrators has the best know-how to install, switch them on, and keep them running. All of these things are things that you need to take into account. So we're about to take an interesting deep dive into everything from raw materials price trends to complete best solutions and system design to the downstream strategies that smart developers should consider. Our speakers today are Samuel Porterbos, Partner and Vice President of Engineering at Clean Horizon, Naeem El-Chami, Lead Analyst at Clean Horizon, and Salome Pepero, who is a Junior Analyst at Clean Horizon. As always, interaction with you, the audience, is really important to us. The speakers' presentations will be followed by an audience Q&A section. You can put your questions for the speakers in the tab you can see on the right hand of your screen. We'll try and answer as many of your questions as possible. It simply won't be able to get through everything we receive, and we're hoping for lots of great questions. But Clean Horizon will be more than happy to reach out to you and reply to any that we don't have time to cover in this session and continue that conversation. So with that, and without further ado or preamble from myself, it's my great pleasure to hand you over to the speakers from Clean Horizon. And first off, that would be Samuel. Hi, Samuel.
Thank you, Andy. Thank you for the great introduction, and welcome everyone to this exciting webinar. So perhaps a few words of introduction of who we are and why we are talking about this topic today. So Clean Horizon, we're a consulting company specialized in storage with basically two activities. One activity is focused on market analysis. We observe the trends, the dynamics, the regulation, the markets, the market opportunities, and build price forecasts and business models of energy storage projects. And the second activity that we have is technical consulting, the activity that I lead, where basically we support developers and utilities in getting energy storage projects off the ground. That goes from the initial feasibility study and designs to the support to commissioning and operation of storage projects. And of course, part of this development support in the development process goes through managing procurement exercises, selecting suppliers, and negotiating contracts with suppliers. Overall, we have, I believe, a full view of the industry and the development of the industry. And the idea today is that we present some of our recent observations that NDU introduced briefly on the trends in terms of product system cost and how to minimize the project cost really at the project level and not at the equipment level. So my colleague Salome and Naim will talk about this today, and we will present a little bit what we see from both the market analysis parts on the equipment cost and on the technical consulting on what we see on project from a project development perspective. So this being said, I'll leave the floor to Naim. Without any further ado, we'll talk a little bit about what we see on the lithium-ion battery trends.
Thank you, Samuel. Hello, everyone. So just like as Samuel said, I will be kicking off this first section of today's webinar by talking about the trends affecting the cost of battery systems and what the main dynamics behind that were. So I start with the conclusion, with the main output that everyone is expecting, which is the curve depicting the evolution of the battery prices over the past few years. So in this chart, you are mostly seeing the cost of the DC system, which means that it is the battery enclosure with all of the integration costs within this unit, being the fire protection system, the cooling system, and any internal cabling regarding this unit. So the prices that you will be seeing do not include the inverters or the transformers that should be coming later on in order to ensure this DC to AC transformation. So in this curve, the main thing that we could see is that batteries have been witnessing battery prices have been witnessing a decreasing trend over the past few years, with a few exceptions. So the first cost decrease was observed over the 2017 to 2020 period, where we have seen prices going all the way down from $260 per kilowatt hour down to around $180 per kilowatt hour. This trend was mostly promoted thanks to the shift from nickel manganese cobalt to lithium iron phosphate, also called LFP batteries, that are by nature less expensive and less reliant on expensive materials such as cobalt, for example. So this was the first trend that we were observing, thanks to which batteries started to get cheaper, in addition to other transformations that you'll be talking about later on during this webinar. However, by the end of this period, by the end of the 2020 period, and as the COVID-19 episode started to run out, a huge demand has come up on the EV industry, an industry which alone by itself consumes up to 90% of the overall lithium-ion battery production globally. So, based on that trend, and coupled with the existing subsidies that were supposed to expire by the end of 2022 in China, we have seen a demand that has by far outpassed the actual supply capacities, which has eventually led to a spike in the prices, going back all the way to $260 per kilowatt hours when it comes to the battery prices. So we were starting to see prices that were quite similar to ones that we were seeing in the early 2018s. So this hike, as I've said, was due to this huge demand. However, In order to cope with the increase of the demand, many battery manufacturers started to consolidate their supply chains by investing in new mining capacities. Some of them by even acquiring mining companies in order to ensure that sufficient lithium carbonate resources were available, so that new gigafactories could open up to cope up with the lithium-ion battery demand, while also ensuring that enough raw materials are available. So this transformation has started to happen in the early 2023, where just by the end of 2023 we started to see prices that went all the way down to around $185, $190 per kilowatt hour, and as of today we are already at average prices of $130 per kilowatt hour. And that being said, thanks to such transformation, this cost decreasing trend isn't set to slow down anytime soon, as we are already expecting prices to go as low as $83 per kilowatt hour by 2030 and $73 per kilowatt hour all the way by 2035. Now, the one thing that I should note here is that these prices represent average values, so some outliers may certainly emerge from time to time, especially if you're talking about gigawatt hour level procurements, in the case of which additional economies of scale could emerge. But these values still represent a good and solid exercise when it comes to apprehending the current cost of the market and the business model of energy storage system. And just to give you a final sense of such transformation between this version of our forecast and in previous iterations, and show you how fast the trends are shifting within the battery storage industry. In previous versions of this forecast, we were expecting prices of $165 per kilowatt hour for 2025 and $130 per kilowatt hour by 2030. While that you can see that we today have already reached or even are lower than $130 per kilowatt hour in 2024 instead of 2030. So all of that shows you once again such an accelerating decrease of the battery system costs. And when it comes to the values, so the source of these values are based on both our experience as owners engineers leading our own procurements, as well as public information and discussion with battery system suppliers. Now, just to go a bit behind the scenes to show you how the stress emerged during mid 2021 up to the end of 2022 on the EV industry, which has consequently affected the lithium-ion industry. So here in this curve, you can see the evolution of lithium carbonate prices between 2018 and last month. So over this period, you can see that by November of 2022, lithium carbonate prices have reached record values, close to 600,000 yuan per metric ton, which has 2 years later fell by more than 75% down to a value of 150,000 yuan per metric ton. So once again, you can see this effect of the increase in mining and production capacities, which has eventually allowed for the demand and the supply to be let's say in a synergy and reducing the stress on raw materials. And in another form, this other graph shows you also this trend on the production level, where you can see that a first spike in lithium-ion and lithium carbonate mining or lithium production has appeared between 2017 and 2018 to start coping with an initial uptake of electric vehicles, and that once again has went on a double-digit rate between 2021 and 2024 to once again translate this demand for lithium-ion batteries and the interest of such solutions. So just to conclude on this one, so if you take up all of the annual growth rates in terms of percents and do the average, you will be ending up with a 14% average compound annual growth rate for the production rates of lithium carbonate.
Thank you so much, Naeem. That's a great start to the presentations today, and talking of great starts, so lots of great questions coming in from the audience already. So please keep those coming in, and yeah, we will give as many of those as we can some airtime at the end. But a couple of quick questions from me before we go on, Naeem. And actually, this first question I was thinking to ask very happily coincides with a similar question asked by someone in the audience. So, Waleed, thank you very much for your question about the potential impact of the increase in battery storage manufacturing capacity within Europe. But Naeem, the initial evolutions, I think it's fair to say they've largely been seen in China, or originating in China, I guess, where raw materials processing and manufacturing has been concentrated until now. But how might we see these trends, including areas such as the relationship with EV manufacturing demand and the potential for overcapacity of cell production? How's that playing out with newer manufacturing centers emerging globally in Europe, of course, in the US, potentially also recently, Australia, I think, has published a national battery strategy and has got some ambitions. And obviously other parts of Asia as well are starting to grow significant capacities of manufacturing.
Yeah, indeed. Thank you, Andy. Thank you, Walid, for these remarks. So that's actually a fact. So today, in a hope to promote local productions of lithium ion and to cope with the local demand, we've seen many geographies make up efforts to promote that. It all started with the Inflation Reduction Act in the United States, where we've seen efficient subsidies affecting most of the entire chain, whether it comes to the production of the cells or even support on the developer side with the ITC, investment tax credit, that would not only help reduce the cost of the battery but also support the development part of the project. We've seen similar more political efforts in Europe, but also from industrial parties, gigafactories that also hope to collocate their production capacities closer to large original equipment manufacturers of EVs, so that they can supply batteries for to be as close as possible to the actual demand. And just like you've said, you've seen additional efforts emerging either in India a few years ago, but also the most recent one being in Australia, where the Australian government has actually dedicated more than half a billion Australian dollars to promote both the mining and raw material processing aspects, but also the actual battery production supply chain, so that a local industry can emerge and even be a competitor to other neighboring ones, like just as the Chinese on the international scale.
Yeah, it's exciting to see, isn't it? I mean, I was fairly recently at an event in Australia, and while I think something like half of the world's unprocessed lithium is sourced from Australia at present, and I think the state of Queensland alone holds about a third of the world's primary vanadium resources as well. So yeah, potential in flow batteries and other technologies there as well. And yeah, it will be really interesting to see if firstly, if Australia can capitalize on that, and secondly, what sort of impact those emerging manufacturing centers might have on the rest of the world too. So that's the raw material side is obviously fascinating, and it's something that particularly during the I hate using the word the pandemic, none of us like remembering that so much, but obviously during that time, was when we saw some of the most extreme we saw the price decline stop for the first time in years, and thankfully that's price declines have resumed. But away from the raw materials side of things, and your colleague Salome is going to talk us through some of the, let's say, the more productized and standardized solutions that are emerging further downstream from the raw materials. So yeah, I mean, as well as the materials and components supply chains that you've just been talking about, Naeem, the performance performance of batteries and the products that essentially form battery storage systems, including the DC block or the DC boxes, and turnkey best solutions have also been evolving. And so to what extent has product evolution impacted costs? And Naeem, maybe if you can start us off on this one and hand over to Salome, and Salome can continue and talk us through the her side of the presentation as well.
Of course. Maybe without spoiling much what Salome would be saying. So I'd say that the first main technological or chemical shift, let's call it, was this move from the NMC to the LFP chemistry, which by nature helped reduce prices on a first iteration. Then the second and most important one was perhaps the establishment of gigafactories that helped battery manufacturers reach these economies of scale, and then they were eventually able to push it even further by transforming their solutions to more, better ones with better performance, better density, and in more adequate shapes and forms, depending on the sizing of the project and its final use.
If I can jump on that. So Naeem clearly state the context of the prices evolution of lithium. And what is really interesting is that there has been some major changes in the products themselves in the last years. So talking about changes on the system architecture of stationary product, on energy density, as Naeem said, and the lifespan of product. And this, with the decreasing prices that we are seeing lately, really play a role in the development of a project, obviously. And so if I may just take a quick chronological approach on this product evolution. So in stationary storage products, we can kind of identify three phases in their evolution. So before 2019, it was we witnessed the start and the boom of stationary products, and clearly driven by the EV industry. And so the question back then was more about the chemistry used, so NMC that came from the IV industry, or LFP, that started to gain traction because of their advantages, so namely a higher thermal stability, or also a longer lifespan. So clearly that was before 2019, that was the trend here. And what we saw is also a proliferation of products, a lot of new market players that were entering the market with their own system architecture, with their own technology, with their own enclosure designs. But after this phase, we see that the industry kind of converged toward two predominant forms of technologies, so namely outdoor racks and 20-foot containers. So I'll talk about it a bit more after, but between 2020 and 2023, it was also the rise of LFP that clearly established itself in the stationary storage industry. But now the trend that we are seeing from 2024 on and in the future is clearly that there is a convergence and a standardization towards 20-foot containers product. And we can notice that also because of big announcements, for instance, of industry leaders that were previously offering outdoor racks and that are now shifting their solution to produce 20-foot containers. So we could, for instance, say that Wärtsilä has launched a few months ago the Quantum 2, which is a 20-foot containers, or Fluence, which is also an industry leader in the outdoor rack supply, that launched a Grid Pro Stack 5000 series, which is also 20-foot containers. So the trend nowadays is really converging towards 20-foot containers, and there is this standardization of product. If we look a bit at the data, and at at the project that we are tracking globally. So on the left chart, top left chart, it's the total power of operational systems as of January this year. And the bottom chart is the project that are announced or under construction. And if we look at the data, we can see that more and more integrators are now supplying 20-foot containers, so in dark blue color, and that by doing so, they are also increasing the market share. On the right chart, it's the classification year by year, and before 2020, some solutions were 20-foot containers, but there was also various products formed in the form of 40-foot containers, walk-in containers, or other specific form from supplier. But then between 2020 and 2023, really the market split into two kind of form, which are the outdoor racks and the 20-foot container. And now after 2023, we see that 20-foot containers are gaining market share, and we expect this trend to continue. And we expect this trend to continue because of the characteristic of the product, because the trend in the market is driven by the characteristic themselves. So just to give a quick overview, I'm here using images to illustrate my speech, but I'm in no case promoting this solution over other solution. But just to say that outdoor racks that were developed between 2020 and 2023, they were kind of the first solution that were fully equipped and that could be transported just like that on site. And that was really convenient. Instead of having to transport the enclosure and then the racks, you can just transport them fully equipped and ready to be on site. And because they are small units, they can be adapted to various size of projects. But one of the drawbacks of the outdoor racks is the extensive cabling that is required, so that the installation can be slower or a bit complex, and therefore it is more expensive. It's becoming more expensive to install on a site. And while outdoor racks were emerging between 2020 and 2023, we also saw 20-foot containers developed at the same time. Again, the image are just illustrative here. And so the characteristic of 20-foot container is that they are really compact solution, and that they can be they are really easy to install on site because the wiring process is easier than outdoor racks. And this form is really used because it's kind of the optimal form of a container, because you can transport it fully equipped. It weighs around 35 tons, and it's the weight limit for truck transport. So that's why they are gaining a lot of market share, because it's really a product that is compact, that can be transported fully equipped, that it is easy to install. We say sometimes plug and play nature. And so that's why they established themselves. And besides this standardization towards 20-foot containers, we also saw trends in the energy density of product. There was massive investment in research and development of cells, and independently of the size, the trend is of a product that have a higher density, always higher density. So the capacity of cell nowadays are typically around 314 amp hour. And a few years ago, it was around 280 amp hours. So it really shows that suppliers have been investing in the cell capacity, and this led to an energy density really high. So just to put in perspective, 20-foot containers of nowadays that are around 5 megawatt hour as the capacity of the 40-foot containers of 2019. So it's really a big improvement in terms of energy density of all solution. And beside this energy density, there is also the lifespan that has greatly evolved throughout the years. So because of the switch of chemistry, the lifespan of the products are guaranteed longer, which allow developers to plan on long-term projects, so PV plus storage or standalone storage or wind plus storage. And so typically for a cycling scenario of 1 cycle per day in 2019, the project was guaranteed for 15 years, while today it's guaranteed for 20 years. And in the near future, some suppliers are aiming to guarantee degradation curves on 25 years. So there is really an improvement in the lifespan, in the state of health degradation. And nowadays, for 15 years, you can imagine, project developer can imagine a project with a cycling scenario of 1.5 cycle per day. So it really shows that there has been some trends and some major changes in the product. So a bit to sum up this evolution, what we are seeing is a mass standardization toward 20-foot products with really high energy density and with a higher lifespan than before, which are like good point for product developer, obviously.
Excellent. Thanks very much, Salome. I think it's so interesting to look at the recent evolution in a collected way like that, you know. And I can just about remember maybe 10 years ago when people were saying, "Oh, this container is incredible. It's a 40-foot container with 0.5 megawatt or 0.5 megawatt hour of storage." And you know, it was incredible at the time. Don't get me wrong. You know, I guess we shouldn't really laugh at the past, but at the same time, things have really evolved so much, haven't they? And yeah, along with that, I guess that increase in energy density and you know, there's also an evolution in the efficiencies, I guess, and the performances. All the different balance of plant equipment people use as well, that's all improving. So yeah, and all really fascinating. And I can see the audience has got plenty of questions about that as well, but we'll save those for a little while, although perhaps yeah, maybe this next question might actually answer one of the audience questions that I saw a minute ago. Forgive me, I didn't catch the name. But so Salome, yeah, if I could just ask, we see this kind of continuing increase in energy density and bigger cells, large format cells to do that. But is it likely the industry will continue to target those higher energy densities and bigger cells, or do you think there's like a kind of a sweet spot which might offer the best balance between factors like performance, cost, and safety?
Well, thank you for this question. As for now, I think that the period for storage products is still about trying to find what is the higher energy density that we can reach for a product. What are the limits? Can we push those limits higher? Clearly, when there is announcements from suppliers, a catch point is always the energy density of the product, as you said, 5 megawatt hour or more sometimes that we can expect in the near future. So I think that it would be difficult to talk about a sweet spot for now, a perfect balance between the performances and the cost and everything. And I think we're still in a phase of the race toward an higher energy density, higher lifespan, and everything.
Yeah, definitely, and it's been really exciting to see. I think particularly in just the last couple of years, as those those price spikes have really we're not seeing the price spikes anymore, and I guess the manufacturers are becoming a bit more ambitious in their designs as well. But I guess that race kind of is something that kind of speaks to or represents the just how competitive the industry is becoming, I guess. And while we've said that say batteries are still not a commodity in the same way as say solar modules might be considered a commodity, there is a lot of standardization going on here, and not just at the cell level, I guess, but also in the whole solution. So from a customer's point of view, how are customers differentiating between the broad range of containerized 20-foot battery storage solutions and the products which are now available? And Salome, if you want to maybe start this one off, and I think Samuel can continue that on and lead into his presentation. But love to hear from you first, Salome.
Yeah, well, of course, one of my, let's say, key points in my speech is that there is a standardization of products. So taking a project developer perspective, it's difficult only to rely on the technical aspect of the products. From a project developer perspective, you have to go further than that because of the standardization, and you have to look deeper into some other aspect of the project. So for instance, the interface management or the allotment strategies that Samuel will a bit more explain later. So yes, I think that's one of the points that are changing now.
Indeed, and I think that's a great transition to what we're discussing about on what are the procurement strategies that can be applied to a project and how this can maximize value of the project. Because as Salome said, we now have very similar architectures from one supplier to another. There are, of course, still differences, but the differences are not on whether you use NMC or LFP batteries. They're not so much into using 40-foot containers versus racks. You will use, for at least for large projects, 20-foot containers, sometimes in DC, sometimes in AC. But the architectures are converging toward somewhat which is, however, standard, meaning that the optimization of a project doesn't rely so much on the choice of architecture and the choice of technology, but really on the overall structure of a project. So typically, what we observe in terms of procurement strategies, I put three typical procurement strategies that we are observing. The first one, the main one, is, and I would say the base case would be the turnkey engineering, procurement, construction, where basically you have one stakeholder that is responsible for the full project. That offers a lot of ease to the project developer because they are limited interfaces, but no interfaces. I must stress that even if you have an EPC, there is still a lot of work to be done to verify that that everything is working correctly and on track for for reaching the agreed COD. But it's still the easiest way for a developer and the way that has the least amount of risk. Of course, this comes with counterweights, and the main drawbacks of this is the cost, because as you have one party typically taking having subcontractors, they will take margins on the different interfaces that they are managing, on different subcontractors that they are managing, such that in the end the cost is relatively high. Here I considered that EPC is a base case to compare a little bit what kind of savings can be obtained in other types of procurement strategies and in other types of contracting strategies. So the main other strategy that exists is separating the integrator and the balance of plant. So in that case, you have two stakeholders, two contracts with the developer, one for the supply of battery inverters, sometimes optionally medium voltage transformers and switch gears, and also very importantly, you typically have the power plant controller, so the local controller that dispatches the inverters of the batteries that is within that scope of supply. And the other part is the balance of plant, which is typically the installation of equipment, the civil and electrical work, and in case of high voltage projects, the high voltage component and transformer. One important point is that so the separation of scope of work can look simple, but really needs to be assessed on a project by project basis, and will depend typically on the integrator and exactly what is the scope of integrator, and especially in terms of control and supervision of the assets. To what extent are they installing and taking under their responsibility the controller and the supervision of the asset, or does it need to be placed, or at least part of it needs to be placed under the balance of plant supplier? Of course, for the project developer, this creates a few more difficulties. First, you need to negotiate 2 contracts. You need to find two suppliers. You need to have 2 procurement exercises in parallel, and sometimes finding a balance of plant can be a little bit difficult because battery projects or on these activities are of relatively small volume for these companies who might prefer wind, solar, or substation works, which are a bit more capex intensive on their part. But in the same time, it does create some savings. Savings come from 2 different sources. The first is obviously that since you have each party taking care of its own scope of work, there is no margin taken on the overall responsibility of the project. So it creates also more risk for the developer, but reduces margins taken on equipment. And that's what we see in EPC, is that when an EPC contractor takes margin on the battery enclosures, of course, it creates a very high cost very easily in the project because the cost of equipment is relatively high, or at least the share of the cost of equipment is relatively high. So that's the first source of savings. The second source of savings is just the sheer competitiveness of the project from the supplier perspective. This is something that we see quite a lot, is that the storage industry is still a vendor's industry, and a lot of battery supplier or BESS integrators are still selecting and choosing the projects they are really willing to work for and really willing to be competitive for, and therefore putting them in their I would say in that sweet spot, and asking them only to provide what they know to provide, meaning the equipment, the battery, the inverters, and the BESS controller, without any local component on their end, puts them in the best position and allows them to make the most competitive offers. So typically, we get 10 to 15% savings compared to a pure EPC. Of course, it's a rough order of magnitude because there can be a lot of variations from one project to another. We've even seen in some procurement exercises larger differences than this between the two options, depending on who were the EPCs and who were the integrators that were participating into the exercise. But overall, quite a significant saving on the project capex. But of course, more risk and more interface to be managed. And the last one is just to illustrate a trend that we are seeing, especially in Europe, which is related to the anticipated purchase of some equipment. And typically that concerns the high voltage transformer, because the high voltage transformer is on the critical path for COD and is the equipment with the longer lead time. Currently in Europe, for European manufacturers, we have lead times of about 24 months for high voltage transformers. That means a COD of the project at least 30 months after signature, which is the lead time that I'm indicating on my slide here. If you anticipate it by 3 months or 6 months, the purchase of the transformer, you anticipate and you reduce by this much the lead time of the project. So since getting to COD as early as possible is very important for developers, this option to go to an anticipated purchase of high voltage transformer is something that we see more and more often, and almost becomes the norm in development of storage projects. So these are the main options. Of course, there are many more options, and basically as many options as you want to imagine. And I think the trend of the industry is to go towards even more separation of scope of work. And it's not impossible, even though it's not an option that we see very often today, because it's still perceived as with coming with a lot of risk, and it's not so not really used as of today, but I think in 2 or 3 years, something that will become more and more common is separation of the battery supply, of the inverter supply, of some part of the controller, and leaving the local content only to the BOP. So we are really, I mean, following the trends of the solar industry typically, where it's very it's very common to procure each equipment separately from one different suppliers. And I think with the standardization that Salome was talking about, and that standardization process becoming more and more pregnant, more and more important, we are going to into that direction. Now, in terms of when do project developers choose one option versus the other, we typically have three criteria for this. The first one is project size. Typically for a smaller project, it's not really worth it to go to separating the scope of works, because the typically managing interfaces and the effort required to have several suppliers is too high compared to the cost saving that you get, and in that case, an EPC procurement is more probably more interesting. And also another point is that battery integrators, best integrators, or best suppliers may not be may not be completely interested by smaller projects lower than 30 or 50 megawatt hours. They'll probably not be competitive in those projects. So that's the first option. Second option is, or second criteria is the financing of the projects and the risk assessment of the and the risk adversity of the finances and investors of the project. If you do very high gearing and a lot of debt financing, you might want to go to turnkey EPC instead of integrator plus balance of plant, unless the investor or the banker has already some experience with storage and is comfortable with the technology, which is not always the case. And the last point is to what extent you are able to manage the different interfaces within a project as a developer, whether internally or with the support of a consultant or a technical advisor, because of course, if you have more suppliers, there's a lot more work to be done to ensure that the project is going to work correctly. And we see some developers that are engaging into that directions, and other that just don't want to take any technical risk and any technical responsibilities on the project. So basically, that's how we are still seeing the different options, and we'll probably continue seeing the different options, but it really depends on the profile of the project, of the investors, and of the developer when it comes to selecting a given option. Now, perhaps just to give a quick view on the cost repartition in a typical 50 megawatt, 100 megawatt hour project, which is kind of the norm, at least in continental Europe. We see a lot of projects around that size. For this kind of project, the battery units represent about 60% of the cost, with an additional 11% for the power conversion system and the MV step-up transformers, meaning that we have about 30% of the cost, about a third of the cost, that is project management and construction, so civil and electrical construction, meaning that even a few years ago, the construction was considered a very marginal part of a project. As of today, it becomes a quite large part. And this is something that also needs to be optimized in a project. Now, as we said, battery costs have gone down. So optimizing cost on the equipment part, especially when you're separating scope of works, is relatively easy, but then the other part is how to optimize cost on the construction side. So finding the right BOP partner and ensuring that there is as little margin and as little cost overruns on this part is extremely important. So yeah, basically, as I've said, on how to reduce project costs, in the end, the key factors are to have large projects. We see a lot of differences between large projects and smaller projects in terms of cost, just because smaller projects are less attractive to at least the main suppliers and the ones that are capable of offering the best cost. Second factor is to increase optionality and competitiveness of the procurement process, just because, again, you want to be attractive for the suppliers. You need to make the project sexy for the best suppliers and for the best integrators to get the best cost. If the project is too complicated, the cost will be too high. And that's the counterpart of the second factor, is to not minimize interface management cost and time and topic during the development process. That's extremely important, especially when scope of works are being separated, especially on the controller part, which is basically the most complex part and the part that always gives a bit of headache in a storage project.
Excellent. Thanks very much, Samuel. Just we'll pause for a moment to let some of that sink in, because there's a lot of information coming here, and looks like the audience want a lot of information from our speakers as well. Lots and lots and lots of questions. So, as I mentioned, we will get those to those in a minute, and everything we don't get through, and there are a lot of questions, and some of them are quite complex. So, yeah, Clean Horizon will be more than happy to follow up with you afterwards. But just before we get into that, Samuel, I think, perhaps with regard to maybe some real world examples, or perhaps if some real world projects that you've worked on might be a bit too commercially sensitive to talk about, could be allegorical examples, let's say. But yeah, what are some of the biggest challenges developers are facing today in contracting best providers and integrators for their projects?
Yeah, so of course there are many challenges, but two main ones I can think about, which I've briefly mentioned. First is finding the right BOP partner and the right separation of scope of work between BOP and integrator, if you are willing to go into that direction, just to make sure that the project is not too complex for the best integrator, that it corresponds to the needs of the BOP, that the architecture of the project allows to reduce costs, etc., and also make it attractive to the BOP, which is a real challenge in the current situation in Europe, where the BOP companies typically have a lot of projects and strong pipelines. And second one is the interface and typically the communication and control between the different systems, making sure that the BMS of the battery, so typically that comes with the battery, can communicate with the power plant controller, that the power plant controller either communicates with the local controller, that it complies with the grid requirements or the grid code requirements, that it allows the supervision of the system, that you have the right communication to the O&M team, etc., that you have the right safety communication and protocols in place. All of this really needs to be designed and engineered, and something that we see very often is that it's a little bit left over during the design part of the project and is only considered in a later stage, which is not a very good practice, obviously. So one very important point is, as in any project, that all the different interfaces and communication need to be managed and tackled early on to avoid problems later on. But that's unfortunately something that we see quite a lot in many projects where these aspects are considered a bit too lightly at the beginning of the construction phase.
Okay, okay. And let's go into these questions from the audience. Or so yeah, if Naeem and Salome would like to join us back on camera as well, that would be great. So Samuel, actually, there was a question from an audience member around basically timings. And I think actually this is a question that I was kind of wanting to ask from my point of view as well. So if we could maybe try and combine Vojislav's question into my question. Let's see how that goes. Bit of an experiment here. But yeah, I mean, I think for a lot of people that have been in the industry for a long time and have done several projects, it may be fairly obvious why kind of getting projects online to deadlines is so critically important for a battery storage system, and maybe more so for battery storage than it is for other kinds of energy assets. So it's really essential to the business case for many projects to get BESS online within agreed deadlines. Now, how do procurement strategies impact that ability? And then if I could just add on, so our audience member was asking if it's often the case that project owners are obliged to go for a limited notice to proceed for ordering critical elements and respect the project timing. So I guess if we can wrap up your, my question about the importance of deadlines, plus what you said about lead times, I guess, particularly for equipment procurement. Does that kind of make sense as a question?
Yeah, definitely. And yes, COD and getting the earliest COD possible is often key in many geographies, perhaps with the exception of the UK, which is already kind of mature industry in terms of energy storage product development. But in a lot of other geographies, the idea is that there is untapped revenues accessible on those markets. And as battery storage products are going to enter the market, there will be a cannibalization occurring, and therefore revenues are likely to go down over the next years. So there is really a premium to be there very quickly and get advantage of those first years of operation, which in most models, including in our models, are typically the most lucrative ones, just because you have less competition on the markets that you are targeting. So that's why even 3 months, 6 months is extremely important because it's 3 months, 6 months of very high value for the project, and that increases the value of the project quite a lot. So yes, and then how to reach that COD, as I mentioned, and that was mentioned in the questions as well, anticipating the purchase of some critical equipment, especially the HV transformer, is one of the main strategies that is being employed. And the rest is ensuring that your suppliers or BOP integrators, EPCs, are respecting and meeting their deadlines, and that typically comes to anticipating the issues that will occur, not minimize the commissioning works, the certification works of the assets. So everything that needs to be done once the systems are on site and installed, there is still a lot of work to be done. And that's sometimes a little bit underestimated. So the point is to make sure very early on in the project that everything is ready, and that we don't have, or at least we have as little as possible bad surprises when we come to that phase, which is the critical phase for the project.
I suppose not many of us are expecting to see high voltage transformer gigafactories coming online anytime soon. So that's always going to be something that's made in fairly limited quantities, I guess. But yeah, okay, yeah, thanks very much for that answer, and yeah, thanks a lot to our audience members for asking as well. So Jana was asking a question, so thank you very much for your question, Jana, on the configuration of the system. So in terms of duration, so 1 hour, 2 hour, 3 hour, or 4 hour systems. How does that have an impact on prices besides the increase in kilowatt hours?
Yeah, sir. Okay, thank you for this question. So when it comes to the cost, so certainly you have the split between the megawatt and megawatt hour pricing, which on the power part should be quite stable, let's say, for the same system. Now it comes to megawatt hours, so this value should at a first level define the number of units that you should be installing on your project. And then there's the actual, let's say, the business case. So the number of hours that you install when it comes to the system should be aligned with your business case, and which by nature should be aligned with the geography and available revenue streams, and eventually the choice of the solution. So as we see today, most of the solutions that are available on the market are more aligned with the what we call the 1C, and more recently the 0.5C rates, which stand for 1 to 2 hour systems that are available on the market. Having said that, it doesn't mean that all of your packages should only be limited to 2 hours. So the way how that's done is that you can install many of these solutions by just playing with the number of DC units in order to reach the megawatt hour rating of your project, while the megawatt part can remain fixed.
And perhaps to comment on the exact cost impact. So basically, on the cost per kilowatt hour of the battery enclosure itself, typically for 1C, so 1 hour battery, it might be a bit higher. Because you have less suppliers that are proposing 1C batteries, so less competition, and also the cells are a bit more specific. But between 2 hours and 4 hours on the battery enclosure part, the difference exists, but remains relatively minimal. Again, in the process of standardization, it's very often that we see 0.5C, so 2 hour batteries being used as 4 hour batteries. So that's one thing. And then on the project level, of course, the BOP side, so the construction part on the connection to the grid and the civil construction, the marginal cost of adding a few containers is relatively small, and the work is not the same, but almost the same. Of course, there's more work, but the increase is quite minimal. So basically, the longer duration you have on your project, the closer your cost per kilowatt hour will converge toward the cost of kilowatt hour of the battery enclosure. So for 4 hours, 6 hours, 8 hours, very easily you'll get towards the $160, $150, $140 per kilowatt hour, which are close to the cost of the enclosure, because the enclosure takes a huge chunk of the cost of this project.
Okay, excellent. Thanks very much. And yeah, obviously the average durations of battery storage systems and energy storage in general, not just batteries, I guess, seems to trend upwards as renewable energy deployment increases. So again, it'd be really fascinating to see how those dynamics around duration play out with lithium ion and potentially, let's say, other technologies. But for today, I think we're kind of focusing on lithium ion. So there's a question or two on safety here. So I guess a lot of the questions were kind of around the general safety aspects of going with higher energy density systems in general. But there's a nice question here from Osama. So thanks very much for your question, Osama, who says that, I believe with the higher cell density, there is a trade-off between the number of charge cycles and increased risk of thermal runaway as the cells are more closely packed. What safety measures are vendors taking in this regard? So anyone want to take that one on?
Yeah, perhaps I can start, and my colleagues can amend that if needed. So when it comes to the actual, let's say, fire protection measures, so as of today, there are several, let's say, approaches that are being adopted by battery manufacturers. So the first and the most important, which is the cooling system. So with time, we've seen today that most of the evolution has been happening on the liquid cooling systems that would offer a closed cooling loop next to the battery modules and the cells by themselves, and that would help mitigate any overheating due to the cycling of these batteries. So that is the first approach. Then the second one would be about adding additional protection measures, whether they are passive, such as the fire rating of the enclosure itself, the separation between the cells to limit the propagation of any thermal runaway event within the modules or even within the racks of a single container, let's say, and more active measures such as dry pipes, water sprinklers, or more inert agents like inert agent solutions based on aerosol type solutions. Now, All of that is important. However, let's say the standard practice today, and that would also be very important whenever you're trying to ensure your project, is making sure that you are complying with local requirements when it comes to fire safety, but also to more standardized and international ones, which usually serve as a basis for insurance companies, like the UN 9540 norm, or other let's say site level ones like the NFPA 855, which should also be setting the guidelines of how you should install your storage system and how your projects should be designed like.
Okay, great. Anyone else on that? Oh, Salome, yeah, sure.
Yeah, well, I don't want to say again what Naim said, but it's true that you should always look at international norms, and that they are going to evolve with the product, I think, just as they evolve in the latest years as well, and reach out to the local fire services as well to have the best practice, and to match those two points together for project developers.
Yeah, I think it's increasingly important from a, let's say, from a technical risk perspective, to be in close contact with the first responders and, you know, the emergency services in that region. But it's also, I think it's a really important aspect of communication, isn't it, with the local community. The local community, I think they should, you know, they have the right to know what's being deployed in their area, and obviously how to best manage that. Yeah, so thanks very much for your answers. Folks, I think we've got maybe time just for one or two more quick questions, if that's all right. And as I keep saying, lots and lots of questions. I'm almost a bit overwhelmed looking through these. It's incredible to see the amount of interest, and yeah, I think Clean Horizon will be able to talk to you about those at your leisure after the session's finished, and, you know, in the coming days. But that said, and no pressure here, where should we go? Where should we go? So there was a question, I don't often do these, but around the presentations themselves, but I think this one might be quite useful for people when they come to look back at the presentation afterwards as well. So Mark was asking from the audience, so the guaranteed degradation curve chart. So I don't know if Samuel, you want to just scroll back to get that one up, or if you can just explain through it in words. But the guaranteed degradation curve chart implies that minimum guaranteed state of health has declined. It was 80% and now 65%. What's the reason for that? And Thierry, also from the audience, was asking why the minimum guaranteed state of health had appeared to have dropped over time.
Yeah, I think that the reason, I mean, there are two reasons. One is technical, the other commercial. The first one technically is that we have better track record over those technologies, because some of the cells that are being used today in the products that are being installed have been tested over 5, 6, 7 years, at least the family of cells that are being used, and through intensive testing, manufacturers have better confidence in what they can do, and better knowledge of how they what's the behavior of the cell beyond the 80%. Another reason is also that we changed technology between NMC and LFP batteries. But I think even with NMC batteries, even though we don't use them much in storage, in stationary storage, we still have this trend that the minimum guaranteed SOH has been reduced, just from a better understanding of the technology. And the second is commercial. There is kind of a race between suppliers to offer the best guarantees, because that's part of the evaluation of the project. And most and that's the way the industry is today, is that business models of storage projects are based on the lifetime that is being guaranteed by the suppliers, and on the degradation curve that is being guaranteed by the supplier. Meaning that if you have a curve over 20 years, you will have a lot more value than if you have a curve over 10 years or 15 years. And that's also why very recently we've seen degradation over 25 years, which are not yet very common, but are appearing on the market as well.
Excellent, thanks. And yeah, unfortunately, last question for today, but yeah, it's been a really good session, I think. And so Hugh from the audience, thank you very much for your question, asks, how do developers and owners manage that trade-off between upfront costs versus life cycle costs, which we could include, product efficiency or quality, ease of providing maintenance, and things like that. And how big is the difference between industry leading companies and others? So yeah, obviously, while we're not here to promote any particular providers, I guess there is some distinction to be made between the top runners and others. But yeah, how should that trade-off be approached, do you think?
Yeah, it's a very interesting question and something not to be overlooked, because that's actually very often the case, that you find very, very competitive capex on one side from one equipment supplier, and not so competitive O&M cost. Typically, the cost that hurts the most during the lifetime is when you purchase the extended warranties, that can be quite expensive, and for most investors and banks investing in projects, it's actually a requirement to get those warranties. So it's not something that is optional in most projects. So in the end, what really matters is to have a total cost of ownership approach. I mean, I cannot really say that one supplier is better than the other on that part. And actually, from a single supplier, we see very, very different quotes, just depending on how the project is attractive to them and how they address the risk that they perceive on the project. So even from one supplier, within one supplier, it can change a lot. But in the end, what matters is really to have a total cost of ownership approach, and not just look at CapEx, not just look at OpEx, but really look at, okay, this is the overall requirement I want over the lifetime of the project. This is how it's going to impact my revenues, and in the end, this is the IRR that I get on my project. So I think that's an important exercise as well, from the economic perspective of the procurement process, to have really a bird's eye view of the project and not look at very specific points.
Fantastic. Okay, thanks so much for your answers there, folks. And yeah, of course, thank you so much to our speakers, Salome, Samuel, and Naeem. It's been a real pleasure appearing in this event with you. Thank you so much. And of course, even more so, if you three don't mind me saying, thank you so much to the audience for registering, attending. And yeah, we hope you had an enjoyable time and learned a few things today as well. As I keep saying, your questions, don't worry, they will get back to you and discuss those in more detail at your leisure. But for now, I think all that remains is for me to say once again, thank you so much for joining. And thank you for all the brilliant work that all of you do in just making this such an exciting, world-changing industry and such a great thing to be part of. So thanks from all of us here at Solar Media, from Clean Horizon and Energy Storage News. And we'll say goodbye for now. Thank you. Goodbye.